So, surds. This is the word we use to refer to square roots that just don't work out very nicely, not as whole numbers. An example of something that wouldn't be a surd would be the square root of 9, because as you should hopefully know, this would just be 3, because 3 times 3 equals said 9. However, what if instead of 9 we had 8, the square root of 8? Now, what's that going to be? First of all, let's actually probably just go over what these square numbers are, just on the left here. So 1 times 1 would be 1, 2 times 2 is going to be 4, then 9, 16, 25, 36, 49, 64, 81, and then 10 times 10 would be 100, but for the purposes of this right here, we're not going to be getting into any numbers so high. Now, as it stands, therefore, if we just wanted to estimate the value of square root of 8, we could notice that the 8 is falling between the 4 and the 9, so it's probably going to be 2 point something, because that's between the 2 and the 3, going to be towards the latter end of those decimal points. But estimating like that probably isn't going to be enough for most questions, so that you may get the odd thing that asks you to make such an estimate. But we want to be exact, and the word exact here is what you will be faced with, saying giving an answer in its exact form. That doesn't always just have to refer to surds, that can also refer to answers in terms of pi or fractions, when basically, to put it in decimals, would be to round inherently. Even if you were to put everything that's displayed on your calculator, you would still be rounding. So the exact form is in that, this surd, this pi, this fraction. Yet nevertheless, we can simplify, and that will be the kind of question that you are faced with. So what we can do is try to split up what's underneath the square root into numbers that can be more nicely square rooted. So for instance, we could say that 8 is the same as 4 times 2. And if you have a multiplication underneath the square root, it has to be a multiplication. We can then split these up into 2 separate square roots. Now here you'll notice, even though we still don't know what the square root of 2 is, we can do the square root of 4 from over here. Square root of 4 is 2. So this will be the same as saying 2 times root 2. And thus, you would have a simplification of the root of 8. We're not getting a decimal value or anything, but we're just putting it in a slightly simpler form. We could also do the square root of 50, which we could split up into 25 times 2, which will be the root 25 root 2, which would just be then 5. Root 2. You don't always have to spell out all of these steps. Once you've done enough of this, if you feel comfortable, you could go straight to something like this. But again, it's always good just to spell things out if you have the time, because it also shows your workings so the marker knows exactly what you're doing, and it also just helps you keep a track of everything. So then just on top of that, we could also have a question that wants these two surds added together. Now, as it stands, there's no real way of combining these. So instead, what we might have to do is rewrite them in these simpler forms, where they're now both in terms of root 2, just like how when you're adding fractions, you need to make them to the same denominator. And now that they are to the same square root 2, we can simply say, if this is 2 lots of root 2, and this is 5 lots of root 2, and you've put them together, that would be 7 root 2. Okay? Now, let's see how you can do on your own. What would the square root of 27 be? And I'd just like you to pause the video here if you want to have a go, and then when you think you've got it, just restart and we'll compare. Okay, so 27 we could split up into 9 times 3, which of course then is just your 9 times root 3, which will therefore be 3 root 3. Okay, so now we've covered kind of the basics of what we're going to be doing with surds. Let's move on to actual examples of questions. Now, as you may see here, these are already slightly different because while you may be asked, just okay, simplify this surd, it's also very possible instead you'll see this technique come up as part of a different kind of question. For instance, here on the top, part A, rationalizing the denominator. That's basically saying we currently have a surd in the bottom of the fraction. We don't want a surd in the bottom of the fraction. We don't mind it being on the top, but just we don't want to divide by 1. So what we're going to do here is start off again with our 5 over root 2, and we're going to times by root 2 over root 2. Now, at any point in maths, if the need arises for it, you can times anything by something over itself, because that's just going to have a value of 1, and times it by 1 and doesn't change anything. This is just rewriting this fraction. It's not changing its actual value. And if we were to do that, that would be a problem. But here, yeah, we can just say that 5 times root 2 is going to be 5 root 2. Here, if we're doing root 2 times root 2, that's just like root of 2 times 2, kind of in the reverse of what we were doing in the previous part, which will become 5 root 2 over root of 4, and we know the square root of 4 is just going to be 2. So this would be the rationalized form. In part B, we're going to have a little bit more. Here, this is also bringing in the concept of expanding brackets, square brackets, or just combining algebraic terms together. Not that this is algebra, but it's the same techniques. If we were to expand this first bracket, therefore, so our 2 plus the square root of 3 times by itself, because it's squared, you'll use the FOIL method if you're familiar with that acronym, first, outer, inner, last. First times first, 2 times 2 is 4. Outer, 2 times root 3 is 2 root 3. Inner, root 3 times 2, so another 2 root 3. And then last, root 3 times root 3, so that's root of 3 times 3, root of 9. Root of 9 is just 3 again. You may notice here, if you have a square root of the same thing just times itself, it is just going to equal whatever that number underneath was. Simplifying here, then got 4 add 3 is going to be 7, and 2 root 3 add 2 root 3 is going to give us 4 lots, root 3 in total. Okay. Now for the other brackets, so we've got 2 minus root 3 this time, and again it's squared, and as before, so first times first, 2 times 2 is 4, outer, 2 times minus root 3 this time, with minus 2 root 3, minus root 3 times 2, again minus 2 root 3, and then lastly, minus root 3 times minus root 3 is going to again actually give us 3, because the root 3 times the root 3 is 3, and a minus times a minus again gives a plus. If the signs are the same, plus plus or minus minus, it makes a positive at the end. Only if it was a plus times a minus would we get a negative. Again, just to simplify, we're now going to have 4 add 3 is once again 7, but here we're going to have minus 4 root 3. To finish off this question then, just because we're going to be minusing these two expressions from each other, remembering we're minusing the whole expression, this is going to leave us with 7 minus 7 is nothing, they cancel out, and 4 root 3 minus minus 4 root 3. Again, a minus minus is going to give us a plus, so 4 root 3 add 4 root 3, so in total that will simplify to 8 lots of root 3. And there you go. Those are the fundamentals of how you deal with surds.